25. Can you show it to me? Do you have it written down or? Oh, yeah. Here, let me grab that real quick. Good one. Limit x goes to infinity, root x squared, 9x squared. Glad you brought this one up. It will serve you well to have gone through this. It's number 25 out of the homework on 1.4, right? Limits infinity. 1.6, number 25. 4, 5, 25, 25. Okay, so what's happening as x goes to infinity here? What is this becoming? Infinity. Square root of infinity is infinity. You take away 3 times infinity, you have infinity. So we have a form infinity minus infinity. Now, when we had that before, we tried factoring something. That's what we tried to break it and turn it into a product. If you look back in the notes from that day, that's what we did. This one, however, is not going to be easy to do something like that too, turning it into a product. So, does anybody have any idea? Conjugate. So where does that come from? So no, seriously, is that your own thought there, or did you get some assistance on it, or assistance? Okay. So from the book, good. All right, that's the way it's supposed to work. All right. It says that when you have something like this, you introduce the conjugate, top and bottom, as like a 1, right? You're introducing a number 1. And because of that, do you have your book with you, sir? Do you know? I would love to see in the book where that was. I mean, it's not that I don't believe you, but just to kind of make the point that when I say you should study the book and everything else, that's what I mean. It goes beyond just what your instructor shows you in class. Plus, yes, conjugate, plus. Yes. Okay, so what we're doing is we're treating this first expression as if it's a fraction over 1. And we're introducing a 1 over 1, a 1 here, which is this conjugate. The conjugate of something is always the same thing, but you switch the sign in between. So if we have a minus here, it's going to turn it into a plus. Well, let's just see where this goes, right, if we do this. Not a natural move, right? That's not something you would think of doing just offhand necessarily. So when I expand this out, I multiply the root and the root together. The roots go away. You're left with just the radicand, 9x squared plus x. Then the middle terms will cancel out, which is the whole purpose of coming in with a conjugate. When you do the 2 middle multiplications, right, this one, that one will cancel with that one because they're opposite in sign. But then your last one will give you the negative 9x squared. All over that ugly thing, right? And now at this point, you can cancel those 9x squared and negative 9x squareds out. And now you're looking at this limit. Limit x goes to infinity of x over square root 9x squared plus x plus 3x. So what we've done is we've converted a limit that was infinity minus infinity to what it looks like is going to become infinity over infinity instead, right? Because we have plus down here instead of the minus that we had up here, this right here, infinity plus infinity is still infinity. But when we had infinity over infinity, this is where we came and we tried to kill off the highest power of x that we see in the denominator, which for us, we're trying to kill off what? X squared. but it's under a square root. So we have to come in with what on the outside? 1 over x, right? Because when it goes in the root, it's going to get squared on its way in, right? You have to get a 1 up here. Careful with that. You don't have to have a 1 on the top. If the goal was to cancel out the top, I would agree with you, but the goal is not to. You can run into some danger there, because what if this was x squared up here? Would you be thinking come in with 1 over x squared? That wouldn't work. Okay, so you have to be careful. Don't focus your attention on that numerator. Focus it on the denominator's highest power, and if it's under a root, you have to compensate for that. It turns out in this problem, it's going to be nice up here. Okay, so limit x goes to infinity. I'm coming in with the 1 over x on top, coming in with the 1 over x on the bottom. I'm going to multiply that times what was here. How many terms are in the bottom? I mean, I guess you could argue with me, but you have the root is one term, right? And then you have plus another term. So this 1 over x will have to distribute through to here and get pushed in the root, and then this one will come over to the 3x. All right, so what do we get on top when we multiply through? That was the nice thing, right? That's just 1. You get 1 up there. Then on the bottom, let's see if you're comfortable pushing this 1 over x through. So 1 over x goes in here, it becomes 1 over x squared on the inside, and that distributes to both of these. So you get root, what? 9 plus x over x squared, which is the same as 1 over x. Anyone have a question on that? On how this going into here gives you this? Yes? When you push something into a root, a square root, when you force it inside the root, it gets squared on its way in. Okay? That's always what happens with the square root. So when this 1 over x goes in here, it becomes 1 over x squared, then distributes to each of these. Okay, 1 over x squared times 9x squared. The x squareds cancel, I get 9. And then 1 over x squared times x, it's x over x squared, that's 1 over x. Now, I'm still not done on the bottom because I need to do what? 1 over x times the 3x. Nothing gets squared because it's not going into a root. So it's just 3, right? Plus 3. 3x over x, 3. And now at this point, you can evaluate. You can take your limit. Let x go to infinity. The 1 over x is going to vanish away to 0, right? And you'll be left with 1 over square root of 9 is 3, plus 3 is 6, 1/6. Right? I stopped writing my limit as soon as I let x go to infinity. That's when I stopped. Does that address your question? Yes? Okay. Mm-hmm. Where is the one in the book? Which page? Okay. Mm-hmm. Okay, yes, that's a good, can I address this? I'm not going to go through the whole problem, but in the book, when they do the conjugate multiplication, they get limit x goes to infinity of 1 over square root of x squared plus 1 plus x, and they don't do any more work. Why? What's the form of this limit? Fixed over infinity. What's the answer to fixed over infinity? 0 always. See, in ours, we had what? Where is it? This green one right here? We had what? Infinity over infinity. And that we could not conclude. Good question. I'm glad you brought that out. But this is a great point. Oh, again, coming back to, it's more than just what I do in class. This is a perfect example of a limit problem that was homework problem that you should have had a question on. But if you do look through the book, there is some guidance to something like this. So, you know, don't go to Rate My Professor saying, you know, yeah, you got to look at this whole thing, right? I don't care if you go to Rate My Professor. I care less, but go ahead. What else? Am I moving through this linearly? Or you want me to just go to number 2 on the review since I did 1? Okay, number 2, I've got f of x equals 3x squared minus 8x minus 3 over x squared minus 9. First thing, find the limit as x approaches 3 of f of x. What is the limit? Like, what do you do when you have a function and someone gives you a function, then they ask you to find a limit? First thing you always try and do, you just plug it in, right? So I'm going to write this down, even though I don't necessarily need to. I'm just going to replace f of x with what the function is. 3x squared minus 8x minus 3 over x squared minus 9. And now when I take the limit in that form, I get 0, did you say over 0? Is that what you get? Letting x become 3. 9 times 3, 27, minus 24 minus 3. Yes, that's 0 on top and then 0 on the bottom. So what do you do in the event that you have 0 over 0? Some sort of algebra, some sort of trick. In this particular case, how about coming through with the 1 over x squared, 1 over x squared? How about that? No? Why not? It's not infinity over infinity. So you don't want to mix up your methods here, right? When you have 0 over 0, you're doing some algebra, some trick. When you have infinity over infinity, that's when you try and kill off the highest power of x. So don't go that way. So what algebra would you like to try here? Factor? Okay, let's see if you can factor the numerator. I'll do the denominator. Three x plus 1, x minus 3. And now you're allowed to cancel the x minus 3, aren't you? As long as you promise me that x will never be 3. And that's okay because the what did I do here? Look at what I just did. I put infinity. Okay. As long as you promise me that x will never be 3, but that's okay because I'm letting x approach 3. That's what the limit means. And now what happens as I approach 3? So start plugging 3 in here and here because these are gone. It's really close to 10 over really close to 6, so really close to 10/6, which is 5/3. So even though you can't plug 3 into the function, as you get closer to 3, it gets closer to 5/3. Any questions there? I've turned my clicker thing off, so you're just going to have to tell me yes or no if you. All right. So that's part A. Part B. What's the limit as x approaches negative 3? I'm going to leave it factored. Yes, I still can cancel those, okay? But here's the deal. Are you getting 0 over 0? What are you getting when you try this limit? You get on top 9, or not 9, you get negative 9 plus 1 is negative 8, right? Negative 8, and then you plug negative 3 in here, you get negative 6. So negative 8 times negative 6. Negative 8, hold on. Negative 8 times negative 6, positive 48. Positive 48, something like that. Fixed number is positive. Is that a fixed positive number? Over 0. What happens when you get fixed over 0? You go to the number line, right? Because you need to figure out if it's going to be infinity, negative infinity, or does not exist. Now, do I specify which side to come in from? No, so you have to check them both. So most likely this is not going to exist unless I get lucky and something happens. But let's just see. Do a number line. What am I plugging in here? What's the number I'm working with? Negative 3. Let's first try coming in from the left side. Somebody give me a number over here. Negative 3.1. What would happen if you plug a negative 3.1 in here? You already know the top's positive, don't you? I mean, you know that it was going to what? It was positive 48 or something. We're going to be close to that positive 48 on top. So I already know I'm going to be fixed positive on top. Over what? So plug in negative 3.1 right here. What do you get? Negative 0.1. And then here it'll be a negative number also. Negative times negative would be positive. So this is getting really close to 0, but it's a positive number. You have to stop me if you don't understand what I'm saying. I'm just plugging negative 3.1 in here mentally and saying those two together give me a negative number. Plug negative 3.1 in here, put those two together, that's a negative number. Multiplying two negative numbers together gives me a positive number. I already know it's getting close to 0. That wasn't the question. It was whether or not it was positive or negative. So from one side, where am I headed? Positive over positive? It's going to go to positive infinity. Am I done? No, I have to consider the other side now, don't I? So if I come in on the other side of negative 3, something like negative 2.9, and I plug this in mentally. Again, the top I don't care about. I know it's going to a fixed positive number. Does everyone understand why it's going to a fixed positive number on top? It's because it's so far away from 0, I don't need to concern myself with it. It was like 48. You know, I'm not going to, by being negative 2.9, it's not going to change it to like almost 0 now, if that makes any sense. So we're always just looking in a problem like this at addressing that 0 on the bottom, determining if it's positive or negative. So plug negative 2.9 right in here, and what would you get? A positive or a negative? Positive. Plug in negative 2.9 here, and you get what? Negative. Positive times negative? Negative. So you have a fixed positive number divided by 0 that's actually just a little bit negative. This gives you negative infinity. What's your conclusion? Does not exist. If all you do on the test is on part B, if I give you a problem like this, and all you do is put does not exist and you don't show anything, I can't give you full credit for that. I need to see some, thought behind it. Because it's like a coin flip almost, right? Three outcomes. Infinity, negative infinity, or does not exist. All right, part C. What's the limit as x goes to infinity? So limit x goes to infinity of the function. So I'm going to rewrite it in the original form. Why am I writing it in the original form and not the factored form? So I can come in with the highest power of the x and do that thing, play that game, because it's infinity over infinity. This has that form, infinity over infinity. And so I will attack it with coming in with what? 1 over x squared on top and bottom. Limit. I appreciate y'all grabbing me a little snack. I'm just kidding. I hear everyone's all, I know. I walked. All I did. That's all I did. I walked. I'm just kidding. All right. Let's multiply that 1 over x squared through. Three minus 8 over x minus 3 over x squared all over. So no root here, right? There's no worrying about pushing anything to the root and squaring anything. This just straight up multiply through 1 minus. Yes. Yes. Yeah. Because what's his name that sits next to you that's gone now, he was asking about, you know, could you just look at the coefficients here, 3 over 1? In a problem like this, you could. But at some point, you'll be forced to use that. So now let's kill off the things that are going to vanish to 0. And you get 3. 3 over 1. I'm so excited. Tonight is my last meeting for the HOA. I'm on my HOA for my neighborhood. I've been on it for, we have a good HOA. Ours isn't bad. Ours is a good one. But I've been on it for like 5 years, and I'm stepping down finally. And I'm just like, I can't believe it. Tonight's my last meeting. So excited. All right, 3. I'll just say this. If you live in an HOA, when you bought the home, you agreed to rules. If you didn't read the rules, that's your fault. I mean, if you want to live by the rules, then you live by the rules. If you don't, then pay the fine and listen to the gripes. But don't say like, I'm gonna live in this neighborhood, and you know what? Wait a minute, hold on. You can't enforce those rules that I agreed to. Whether or not you don't like them, well, it depends on neighborhoods. You know, it depends on the neighborhood. I don't know what nice is. You know, I mean, our HOA costs $600 a year. Okay, or $660. Sorry. Dominion is like $15,000, $20,000 a year. I don't know. In Dominion, if you leave a car parked on the street, I don't know what they're going to do to you. You know what I'm saying? They probably tow. You know, so I mean, okay, we're going to go off topic real quick here. So I'm excited. Are we done with that one? No, part D. Darn it. Part D, holes. Okay, how do you find the holes of a function? Anywhere it's 0 over 0. Where was it 0 over 0? We had already addressed that, hadn't we? It was 0 over 0 in part A when we were trying to approach 3, right? That means we have a hole at 3. Yes. There can be, yes. What we would have to do is figure out everywhere it's 0 over 0. But if we look at the function, it factors to be 2 binomials, right? There are only 2 places where the denominator can be 0. One of them is 3. When we plug in 3, we also get 0 on top, so we have a hole. The other place the denominator could be 0 was at -3, but the top wasn't 0 there. And that turned out to be an asymptote, which is the next question, all right? Does that answer your question? So if you're looking at the problem in big picture, you have to go back and look at everywhere the denominator was 0. And just make sure that the numerator is 0 at the same time. So I'm going to say here, the holes are going to happen whenever we get 0 over 0, but that happens only at x equals 3. And therefore, x equals 3 is my hole, right? Was it 3? Negative 3. It was 3? Okay. Part E would be the horizontals. Oh, I'm not asking for verticals, am I? I didn't ask for verticals. Let's do that after this. We'll just make sure we got it down here. The horizontal asymptote, what's the horizontal asymptote? That's what you get when you take the limit as x goes to infinity of your function. And we already did that, didn't we? That was part C. And what did we get? 3? Y equals 3. Now I put y equals 3 because a horizontal asymptote is a horizontal line. And so we need to define it as a line. So we say y equals 3. Y3 is that line. If you just put 3, I wouldn't like take off a whole bunch. But, you know, there's a difference between saying 3 and y equals 3. Y equals 3 specifies a horizontal line. All right, and so this, I'm adding this in here, part F. How about your vertical asymptotes? That's going to happen anywhere you have what? Fixed over 0, and we already determined that that happened when x was negative 3. All right, let's move on. (3a). So we've got this guy, right? With that, we have a lawyer. We just send a lawyer. But it costs us money. It costs every resident in that neighborhood money. They all do. They all do. If you're part of an HOA, then your management company has a lawyer that you would have to employ. It's like they're on standby waiting, and then if we have to call on them, we have to pay them. We, the community, has to pay to make up for this person's mistake. Okay, 3A. All right, what about this? What's the form of this limit here? Careful. I'm hearing a lot of things, but what's the form of the limit? Do not let me catch you with the limit where you start doing all this crazy math on it and the limit was just 2. Let h go to 0 right now and see what you get. It's 1 over root 2 minus 1 over root 2, which is 0 over, it is 0 over 0. 0 over 0, which is 1. And then we just move on to the next problem, right? Honey, someone's going to do it. Someone's going to do it.
What if we put like a jet?
That's fine. You can put a little smiley face there. All right, so I heard conjugate. That's correct. I also heard least common denominator. So both are correct. You can't do conjugate till after you get a common denominator. Because you can't, well, no, you've got to get this out of the denominator. You've got to get the h out of there because it's got to cancel with this h. So let's first find an LCD, least common denominator. To do this, I'm going to multiply the top and bottom of the first fraction by root 2 over root 2. The other fraction, 1 over root 2, I'm going to multiply it by what? Root 2 plus h over root 2 plus h. All of this over h. Okay, so I'm just trying to get a common denominator, that's all. When I put these together, I'll have the numerator up here, which is what? Root 2 is the top left part. What about the next part? Top right. 1 times root 2 plus h, right? And the minus, right? And that minus doesn't distribute the roots there. You can't distribute through a root. So minus root 2 plus h. That is divided by the common denominator, which was root 2 times root 2 plus h. That's all over h. Okay. Now you come in with conjugate after that step. So if you're looking at this, if you see a complicated fraction, you always want to try common denominator first. If you see roots, you'll want to do conjugate, but you want to do them in that order. Here was roots and fractions. So do your fraction part first, common. Now your conjugate. What's conjugate? Conjugate of what? What do we? Conjugate of this piece. This doesn't have a conjugate because it's multiplication. Conjugate, you have to have addition or subtraction. So I'm going to come in here with root 2 plus root 2 plus h over root 2 plus root 2 plus h. That's a 1 right there. So that's valid. Go straight across here, straight across here. All of this over h when I'm done. Here comes some parentheses to help me out because I'm going to have to do an expansion or a foiling of that. On the bottom, what have I told you to do with this bottom piece? Just to leave it alone. Don't try and put them all together. If you're going to get an h to cancel, it's going to come out of the top. It's not going to come out of the bottom. So multiply it out. Lim h goes to 0. Root 2 times root 2. 2. The middle terms cancel. Minus 2 plus h. But in parentheses. Right? Because that last multiplication, these two, when you do that, you get a 2 plus h, but you're subtracting the 2 plus h, so got to put it in parentheses. All over that ugly thing, which was root 2 plus h, then in parentheses, root 2 plus root 2 plus h, and then all of this over h. Distribute the negative through that parentheses, and good things happen, right? You limit, h goes to 0. What are you left with up there when you distribute that through? Negative 2, negative h, and the 2 minus 2 is going to go away, and you'll be left with negative h on top. Over root 2 plus h, parentheses root 2 plus root 2 plus h. Oh wait, root 2 plus h. All of that over h. And we have reached our objective, which was to get it to a point where the h would cancel. I'm going to go one more line, even though you're probably ready to let h go to 0. Just want to make sure we're all in the same place here. I have now a negative 1 on top. And on the bottom, root 2 plus h, parentheses, root 2 plus root 2 plus h, close parentheses. Now let h go to 0. So no more limit, okay? No more limit. Here it is. Negative 1 over root 2 times root 2 again, in parentheses, root 2 plus root 2. Negative, well, careful. This is root 2 plus root 2. This one right here, these multiply together to be what? 2? These add together to become 2 root 2. So it's going to be 4 root 2. Negative 1 over 4 root 2. So this equals negative 1 over, I'll go a little slower, 2 times 2 root 2. So what's in parentheses here is what's in parentheses here. Root 2 times root 2 is 2. Multiply 2 times 2, negative 1 over 4 root 2. I don't, but I will do it just so you can see. If you do rationalize root 2 over root 2 is what you would do. And you would get negative root 2 over what? Yep, 8. I boxed the ones that would be correct. Any questions there? Keep going. Let's do B. B doesn't look nice. Evaluate means just figure out what these limits are. I don't know what you mean by the whole process. Yes. You need to figure out what these things are doing. Oh, you know what? I never thought maybe there's a class in here. Hold on. There's a class in here at 3:30. You don't want to move to a different location? Try and find a different room. I totally forgot about that. This one's easy. You know what? The rest are all easy. No, I'm kidding.